Hello everyone, my name is Jess, and I'll be translating for the host, Young Han, and all the speakers we've invited to GitDeun today. First, we'd like to briefly introduce you to GitDeun, the organization that's hosting today's AMA. So what can you do with blockchain? What exactly is Web3? These are questions that probably almost everyone has asked when they first became interested in blockchain. And despite most of our team members having been in the field for a pretty long time ourselves, we still find these questions really difficult to answer. GitDeun was founded from our desire to help create a world where these questions can be answered without, a second thought. So the name Kitun comes from a Korean word that doesn't really have an accurate translation in the English language. So here's the definition that we came up with. Kitun refers to the state of being unnoticeably immersed in harmony with its surroundings. And as the name of our alliance suggests, we want to make blockchain technology and Web3 harmoniously immersed in the lives of more people. And to do this, we believe that there should be a space where existing Web 2 and Web 3 companies can actively interact with each other. And we'd like to create that space and be the hub that connects them. We believe blockchain technology and Web 3 will be more accessible to the general public when someone decides to step up and connect Web 3 and Web 2 companies. So, starting with today's AMA, we'll continue to introduce and incubate projects, organize meetups, marketing, in addition to other activities to make blockchain and Web3 a part of everyone's lives. So stay tuned for more. So I explained this earlier, but for those who have joined us a little bit later, after the AMA, we've prepared a fun quiz / trivia session for our community members. There will be prizes worth up to 200,000 Korean won, which is about $150 in US dollars for the correct answers. We'll proceed with the quiz session through text in the AMA-live channel right after the AMA. The quiz will include questions from today's AMA, so we recommend you to try your best to stay focused, but not all of them will be, about the AMA. So for those who are, not strong in terms of developer lingo, there are questions ready for you too, so don't worry too much. All right, I think that should be enough to introduce Kitin, and now it's time to introduce our guest of honor. We'd like to welcome the team from Cartesi. Cartesi is building an application-specific roll-up solution with the Linux runtime for better scalability and programmability in today's ecosystem. It's an honor to welcome them to the first AMA hosted by GitDeun Alliance. Our speaker today is Gabriel Barros, who is the developer advocate at Cartesi. Hey Gabriel, we'd like you to please introduce yourself and say hello to the GitDeun fam.
Okay, thank you. Hello, guys. It's been a pleasure being here. I was very excited to receive this invitation. Thank you for all the work to make this happen. I'm Gabriel Barros, like you guys are saying. I'm developer advocate for a little while at Cartesi, but I joined the company as a smart contract developer for Ethereum, and I've been working at Cartesi for 3 years now.
All right, thanks for keeping it short. It makes my job easier. Yep. Is there anything else you wanted to say, or we can move on if you'd like?
Oh no, yeah, I just like to add, since in the spirit of introducing myself, I've been working with blockchain since 2016. I was hired as soon as I graduated, and I worked at Consensus. It was a hectic time, lots of interesting projects, and I've been migrating here and there until I found my university friend and at DevCon Osaka. And when I met him there presenting Cartesi, I fell in love with the project, and then I joined Cartesi. Shall we move to the presentation?
Yeah, just maybe one last quick thing. Do you have any advice for people who want to work in the blockchain scene, based on your experience? What steps should they take?
I'd say it's very important to understand why blockchain. What does make it interesting or important? Because once you get it down, you're gonna be able to understand what you should do in your own career, be it marketing, be it design, be it software development, to actually become an interesting person, an interesting employee for new projects, or even as you get to understand it, to start your own project.
Thanks, Gabriel, for your answer.
Yeah, sure.
Yeah,
Yeah.
and I think we can move on to your presentation. Let me just quickly explain that we're going to move on to the Cartesi introduction. And then I think we can get started. 네,
Nice.
Gabriel, I think you can get started. You can go ahead and share your screen if you have your presentation ready.
Yeah. Quick question for you. Are you gonna try
Yeah.
to translate as I go, or are you gonna give us a summary afterwards?
You're going to go through your presentation. I don't want to interrupt your flow. So you're gonna go from start to
Okay.
finish. And since I know like the gist of what your presentation is gonna be, I'm just gonna summarize it in Korean after you're done with that, with your
Awesome.
presentation. Is that okay?
Sure, sure.
All
Awesome.
right.
Okay, guys. So getting started. Today I'm gonna explain a little bit what Rollups does and how Cartesi has been leveraging Rollups to bring Linux to the blockchain. So as a quick overview of what we're gonna cover, I'm gonna explain a little bit why Cartesi, how we came to be here, the rollups, as I said. Then I'm gonna show a little bit the development comparison between Web 2 or the legacy world and what Ethereum and Cartesi are bringing, so people have a high level understanding. And finally, I'm gonna show a little bit how it actually looks like into coding. So by the end of this presentation, I expect to be able to make you guys, that are developers, to understand that this is actually a smart contract. So Cartesi, how it came to be. So Cartesi started as a attempt to make a AI marketplace, so a place where you could share the data sets between a few friends that were mathematicians and wanted to leverage blockchain. But as they developed the idea, they understood that they needed to create something to make verifiable computability. So this is a mouthful word, but it's gonna become understandable as we go through the presentation. So going back to Ethereum, Ethereum is awesome because it's the first blockchain that introduced smart contracts, as we call them. So basically, the ability to compute things in the um, uh, in a transparent form where people could trust what you produced. So it brings some awesome properties as it is secure, censorship resistant, decentralized, and much more things that it brings. But at the same time, those things they come with some liabilities or downsides, because everybody's ensuring that the whole network is correct. It makes everything more slow. Also makes things more expensive because it can only have so many computations there, and that also brings a cumbersome API because now you're computing in a different environment. You're not in the wild. You're not just in a generic server. So it's harder on the developer who's getting started. But what if we could have all the security, censorship resistant, and whatnot that Ethereum brings, and still maintain the complex computations that we already use in our day-to-day lives? And that's where Cartesi comes. Cartesi created a computer emulator based off RISC-V. RISC-V is an instruction set that is open source, so it's just like Linux itself. So everybody can collaborate on that. And that processor is just like your Intel AMD, but you don't have copyright problems with it, in not so many words. So this means that Cartesi created a virtual computer where you can have any OS running on it, and we brought Linux. That means that now, instead of dealing with a limited machine, just like EVM, you actually have a full server where you can use any language to code with. And that is only possible, the whole Cartesi solution, that's only possible because of these three main pillars that I'm going to go through right now. The first one being the Cartesi machine that I was explaining. So open hardware, anybody can use that. That means that several companies are auditing at all times, making it more secure and resilient. It's a platform processor, so it's just like a server. We made it deterministic, meaning that it always gonna end up at the same place after some process, meaning if you calculate 2 plus 2, it's not only gonna tell you it's 4, it's gonna tell you it is 4 using the same amount of steps, the same amount of energy, the same, as we say, amount of CPU cycles. So it's easier to get an agreement with anybody else about what the process you're running was supposed to be doing. And that means that we can bring massive computation to the blockchain. The second piece is what really sets Cartesi rollups apart from many rollups, which is the local consensus. So if you look at Ethereum and many other networks and even rollups, they use what we call global consensus. So the more computer you add to the network, you're just making it more secure, but you're not increasing the capacity of the network itself to handle more transactions and processing. So that is not all bad though, because that brings composability to it. So all the dApps, they are basically sharing the same machine, so it's easier to communicate. So you can start a transaction in your smart wallet, sending something to Uniswap that can trigger a loan contract. That is nice. But at the same time, that means that if any application becomes really popular, it's going to hurt the other applications because the gas cost increases really quickly. Then you have local consensus, meaning that you have this smaller network, so to speak, of validators that use Ethereum network to secure it. However, as they are processing the information, they do not share the same resources. Meaning here that DAP A, DAP B, and C, they are completely isolated from each other until they go back to Ethereum. So that means that if by any chance DAP B becomes very successful, suddenly, from overnight, it becomes like a meme or super popular. It is not gonna hurt DAP B or DAP C in any way, because they are not sharing the same resources at all. So gas cost is not gonna increase for it. And meanwhile, DAP B can actually adapt quicker because now that DAP B is isolated, people can come into agreement on how to change parameters of the network to adapt to the current situation they're facing. And finally, the dispute protocol. So how come you can have so little nodes and still be secure? It means that first, we can only deal with the interested parties. So if we are going to a DEX, a decentralized exchange, you don't need to be facing a challenge with everybody using the network. We can actually just look for the people who are in disagreement and they can run the verification process. That's first. Second, there is no collusion possibility. Because the computation is verifiable, you can use Ethereum as a judge, meaning you can find exactly where two people disagree with and find the exact CPU cycle, which is a very small computation, and put that on Ethereum. Once you can run this one CPU cycle on Ethereum, which is, by the way, very cheap, you can use the full power of Ethereum to protect the honest party. So even though you can maybe have 100 validators and 99 is saying the sky is red, if you have at least one person saying no, 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 the sky is blue, Ethereum can help this one little guy actually ensure that the information posted to Ethereum later is actually the correct one, which is the sky is blue. That means that the correct settlement is ensured. So how does a rollup actually work? Because here I've been talking high level, but for people who are not familiar with it, maybe it's a little bit strange. So any rollup, being optimistic or zero knowledge, actually starts like this. At a certain point, you're gonna send a transaction to Ethereum, and that transaction is gonna be included at one block. And what it states is, I have some kind of computation here that I want to process off chain. And the initial state of that machine, of that computation, is actually such and such. So you have a Merkle root hash, meaning you have some kind of Merkleized process that is summarized in that initial transaction over here. So anybody interacting with Rollup from here on out is actually implicitly saying, I trust that the initial state of this was correct. I can verify it myself because I have a copy of the code, I have the copy of the node, meaning I'm ready to go. Now, you go on sending transactions to Ethereum, but they are quote unquote dummy transactions. They don't do any changes on Ethereum. They are just registered there. It's just like a notary. You're just saying things that's supposed to happen and you're noting them down, but they don't actually are they're not made effective at that time. Now, the process of chain will read those transactions that you're sending, and it's actually gonna change things here off chain. And after a while, most rollups have been using the window of 7 days. It's gonna summarize that into a new state, a new final state, and it's gonna be posted back to on-chain, to which, depending on the type of rollup, let's say optimistic rollup, you're gonna finalize in 7 days, meaning people have 7 days to complain about what's being said to be right. If nobody complains about that, it's taken as correct. And that final state is actually a new initial state. So technically, you're renewing this agreement throughout the time every 7 days. So a final here is actually a new initial state for the second moment. And how does it actually look like when we are talking actual development, right? So here I have a very quick summary of how legacy kind of works. You have some kind of UI here represented by the browser, and you have some custom code to manage the UI, and you have several types of connections, mostly let's say HTTP, HTTPS, connecting to a centralized server somewhere, and it can be actually a cloud computing, so some centralized service connecting to the same model again, to some set of centralized databases. And that is very common. And Ethereum changed it a little bit. So you can still have this, but instead of having the hard logic in some server that somebody can shut it down, you can actually change that to a connection to a JSON RPC, which is just the standard connection to Ethereum nodes, to the Ethereum blockchain itself. So meaning that you could be running your own Ethereum node, but you can be connecting to services such as Infura. And what you're gonna see is that UI is gonna have some abstraction library. The most common ones are Web3.js and Ether.js, and that is gonna deal with the hard logic for money, for the states of games, for anything that isn't supposed to be centralized at all. Cartesi, it has kind of the same shape. Here's a simplified overview. You're going to have some sets of libraries written by you, by the community, or Cartesi itself, that's going to connect to some kind of Cartesi framework. And the only difference here I'm choosing to display is that instead of having the EVM inside of that node, inside of that Ethereum blockchain, you're going to have this virtual machine, the Cartesi machine here, with their custom logic code, this step backend over here, that can be written in any language, such as Python, JavaScript, Java. And it's going to be communicating with a little API that we put inside. Let's call it a rollup server. And if you get that, what we need to understand here is actually that we need just a little bit more connections, actually. That simplified overview is broken into three types of connections. The connection that you still do to Ethereum, because you need to register those dummy transactions I was talking before. Your quick connection to the nodes, so you can populate your UI and know what state is happening there. And finally, a graphical API that you can use to see what is being generated inside the Cartesi node. And starting with the first one, we still have the JSON RPC to Ethereum because we cannot provide data availability. What is that data availability problem? When you have computation and you have verifiable computation, you need to be in agreement of what is the data that the computation is processing. So I can tell anything about a chess game board. What are the rules? What are the moves? And I can even tell history as long as we agree what are the moves made by players. Why is that? Because if I do a move and you just trust me and you process the thing off chain, later on, if I lose, I can just play not cool and say, hey, actually, I didn't do any of these moves. And without the verifiability of the data itself, you cannot prove to Ethereum that actually you won the game. So in order to invert this problem, you register all the data on Ethereum itself. That is the dummy transactions I was talking about. And Ethereum becomes like a notary or a newspaper. It's like every time you do a move in the game, you're publishing it to the newspaper. So the whole community knows what are the actual sequences of the moves that two players did on a game, for instance. So that's why you still need to use the JSON RPC connection in a Cartesi app. Then moving on, we can check what is being produced. So in the graphical API, you're going to check for three main types of outputs. Just like in Ethereum, you need to check what is going on inside, right? So the first one is report. Report is much like a log, but instead of being just on the screen of the server, you can actually reply back on the API. So you can have remote connections to the node. Then you have a notice, which is like an Ethereum event. And this little guy here is a bit special because it's an Ethereum event that you can prove to Ethereum itself. So whenever a Cartesian node produces a notice, you can actually go back to Ethereum and check whether or not that is true. And then you have a voucher, which is very similar to a notice, but instead of being just any random information that you choose to log, it is actually a transaction that will be executed in the future. So a person joins the rollup, but later on they want to exit and withdraw the money. What actually they're going to be producing is a voucher that in the future is going to be executed, and it's going to execute a transaction returning the money back to the person, for instance. Then we have the rollup server I was talking about. Just go back here 1 second. This little guy over here. This is the most important one as you are producing your node and you're producing your Cartesi app or your smart contract, if you think about it like that. And it's just an HTTP API. So if you're used to develop like with REST APIs, this becomes quite simple. And what it has is like four main endpoints. One that will keep feeding you with new information, which is this finish guy over here. This is what is gonna put your machine to sleep and reply you with new requests. We're gonna see an example of that. And then you have three types of endpoints here, which you can use freely to create new vouchers, notices, and reports, like I was saying before. And that makes the whole development very easy. And with that, we saw all the APIs.
Hey, Gabriel. I'm gonna have to ask you to wrap it up within the next minute or two. I'm
Sure.
really sorry, but I think I asked for the presentation to be about 10 minutes max, but I think we've gone over the time limit a little bit.
For sure.
And I think our Korean listeners are having a hard time understanding, so we're gonna have to wrap up within the next minute, and then I'll go over the Korean translation.
100%. I can do it.
Thank you.
For sure. So, just like I said in the beginning, what is this doing? This is sending a new input, so a new payload to be processed by the Cartesi node over here on the yellow side. And on the blue side, you can see a Python code that we'll be connecting to the rollup server I was talking about. And then over here, line 23, you're going to see that it starts to request things. So that's the finish endpoint. And once it processes the rollup request, you can see that it's going to actually call one of these handlers here, let's say advance. And this is an echo Python, meaning this is an example that whatever you send to it, it sends it back. So here it's copying the data you just received into a new notice. It creates a new notice over here, line 8. And finally, this is a infinite loop, so meaning at line 24, it finishes the whole request and goes to sleep. So whenever you check for new notices created using the CLI tool, you're gonna see that there is the same payload over there. And that's a quick run through of the code, showing that the endpoints I was talking about before. You can go ahead.
Are you finished with your presentation?
Yes, I wrapped up the code piece. Yep.
All right, thank you. Thank you so much for your presentation. You've really prepared a lot, and it would be, great if we could listen to the full version. But we can forward the link to your full presentation that you sent us to our community members that are here today. If that's okay with you.
For sure, for sure.
All right. All right, so thank you, Gabriel, so much again for the great introduction. We're really looking forward to today's AMA. And we're going to move on to the pre-questions submitted by the Aslan Academic Club members who have joined us for the AMA today. To the community members, please understand that due to time constraints, we won't be able to cover all of the questions that have been submitted, but we've chosen to focus on the questions that you won't be able to find the answers to through research or external materials, but provide you with all the opportunity to hear the answers directly from the Cartesi team during our AMA today. We'll be rewarding one member from those who submitted pre-questions, whose question gets chosen as the best question or their favorite question by the Cartesi team. As well as those who upload live questions here on Discord. So stay tuned and we encourage you to participate. Now let's get started on the questions that we've prepared for Gabriel and the Cartesi team. All right, Gabriel, here is our first question that we've chosen from the pre-submitted questions. I'm looking forward to this AMA because Cartesi seems to make it easy to develop and run dApps. I think it'll make the blockchain scene more accessible, especially for junior developers, by lowering the technical barrier. I'm curious about your values and vision for Cartesi. More specifically, how would you introduce Cartesi to a junior developer or someone who's just learning to develop?
Okay, thank you. So For this first question, I'd say Cartesi is an application-specific rollup with Linux runtime, which is in simple terms, it brings Linux OS to the blockchain through the Cartesi machine. This enables developers to incorporate decades of open source knowledge into the blockchain and to build dApps using the preferred libraries, compilers, languages, and other well-established open source tools. It may sound too much and complex, but actually Cartesi simplifies the process of developers to code, meaning it brings flexibility to create apps using Python, Rust, Lua, JavaScript, and it does not make it limited to Solidity. Also, Cartesi prevents Ethereum from becoming a rich people playground. So whenever a new trend emerges, it just becomes expensive, right? So when it comes to the gas fees, that's why we advocate for each dApp to have its own chain and its own consensus mechanism. And by not being based on the EVM, it creates a better synergy between data capabilities, computational power, and programmability. Cartesi's mission is to advance the entire Web3 space.
Thank you so much for your answer to our previous question, Gabriel. And I think that was a great question to just give a summary or like an overview of what else we'll talk about today. And a great starting point for our pre-submitted questions part of our AMA tonight. We're going to move on to the next question. Here we go. What changes do you think Cartesi will bring to the blockchain ecosystem, and how does Cartesi differ from existing blockchain projects?
So I'd say, in a nutshell, Cartesi offers both computation and content scalability, allowing for the creation of more expressive and computational intensive dApps. So Cartesi provides Ethereum and other L2s with orders of magnitude more computational power. There are some key features that Cartesi to make that quite unique. So dApps are deployed on their own customizable application-specific rollup chains and don't compete with each other in the Cartesi ecosystem for the scarce block space. dApps preserve the strong guarantees and censorship resistance of the underlying blockchain. So like this, there is finally a good response to the blockchain trilemma of scalability, security, and decentralization. So Cartesi rollups can also be deployed as a layer 2 on top of Ethereum or as a layer 3 on top of Optimism, Arbitrum, all these other layer 2 solutions. So, and in the future, possibly as a sovereign rollup. This opens up the whole new world of possibilities for the blockchain industry.
Thank you, Gabriel. We hope that your answer to our previous question has, piqued the interest of quite a few of the members that are listening in today and will, continue to keep their eyes on Cartesi. Okay, our next question is a little less development related, and hopefully it'll lead to an answer that will be easy for non-dev members in our community to understand. Here it is. What was the biggest challenge the Cartesi team faced, and how did you overcome it?
Okay, sure. I hope that I can pique the interest of the other people as well. So I think every great project's biggest challenge is the next one. However, in the spirit of the curiosity of the question, I can think of one good challenge that we faced while creating the Cartesi machine. So every day we use devices with processors that are quite similar to those in laptops. What most people don't realize is that these processors can be somewhat chaotic in the quest of optimizing for speed and energy consumption. While they're generally reliable in providing answers to our queries, the inner workings can be quite random and prone to errors, which they continually correct. That's why we don't perceive it. So this represents a problem for Cartesi. How can we use such processors in a rigorous environment like the blockchain, where predictability is crucial? And the answer lies in years of research and development and that the team had. And we overcame this challenge by essentially recreating the CPU in a similar manner to how Intel and AMD develop their processors. We followed the RISC-V build point, imported to the Ethereum chain. And as a result, you can now put any OS on chain, which is an amazing feat.
All right. So if you have any questions you'd like to ask live, I'm speaking to the community members. We're gonna ask you to just start posting them in the chat room we have here for this AMA. And if you need to post in Korean, then we can translate it for you and use that to ask Gabriel and receive the answer. All right. I think we can move on to the next question. Here it is. I was wondering if Cartesi has any plans to organize a hackathon or any other offline events in Korea.
Oh, sure. Yeah, we'd be happy to organize a hackathon if there is a Korean community of developers eager to use it. We recently held a in-person hackathon with the Thinking Dev. They are software developers in Argentina, and another one in Dallas, Texas. And finally, another one with the University of SMU, together with a blockchain collab. And now we are just in the verge of doing another one with the Brazilian team with some students here from São Paulo. So we are very open and we would love to do something similar in the future in Korea as well. Until then, we encourage everybody to check our documentation on docs.cortesi.io and start building. So we host several online hackathons. We just finished our own global online hackathon in October, and we are gonna join the East Global's online hackathon coming, I think, in October. We welcome everybody in our Discord as well, where we're happy to provide technical support to anybody. Also, if anyone has any creative ideas for a project, we welcome to a grant application where developers can get funding to get started on building their own dream dApps.
Thank you, Gabriel. This sounds like an amazing opportunity for both developers and project or product managers. I think I'd definitely be interested in participating if Cartesi were to open a hackathon in Korea. I'm not a developer, but I personally have a lot of interest in the blockchain field, and I have a lot of ideas, so maybe that's something I might be able to do in the future. So we are going to finish up with our pre-submitted questions due to our time constraints. And we're going to start our live question section. So we've asked our community members to post their questions in both Korean and English. So I think we're going to give them a couple of minutes to start posting. I already see a couple here. And I think we're gonna choose around 4 questions. 저희 현장 질문 4개 고르나요?
네, 맞습니다.
네네. So we're gonna choose 4 questions. And if you see a question that you'd like to answer, you can go ahead and answer. Is that clear?
For sure.
All right.
And Barros, if you
For
could you reply to the question that you're going to answer for me, so I know which question you choose?
You mean from the chat right now or from the
Yes,
previous selection that we had?
no, at the AMA live channel. The people are writing the question right now at the moment.
Yeah,
So
I see one that I don't quite get it. Maybe it's mistranslated. One from
Gabriel,
what? Hi.
this not the chat room for this AMA stage. If you go to the left side, you see the list of channels, right?
Oh, yeah,
If
yeah, I
you
see now. Am I live?
yeah. So we've got a lot of questions coming up there.
Oh my God, yes.
So just take your time to look through, and I think you can choose 4 questions. Just let us know which questions you're going to answer before you answer them.
I see.
Okay.
So, how many questions do you want me to select? There are so many good questions here.
4 of them, please.
4.
4. Okay, how can I reference them? So, um, there's one saying, what are the main difference and advantages of Cartesi compared to other layer 2 rollup solutions?
Could you give
How,
us the username for whoever asked that question?
give you?
Could
Give
you
you?
reply to the sentence? You
I
have to.
can, like, maybe I can do it like this. This one? Can
Yes,
you see
yes,
that?
yes, yes. I
Yeah.
see it. Just like that. And please answer the
Oh,
question
okay.
for me. Yes.
Okay. There was, this one it's fun as well. There is one more that I saw that was really good.
And one more.
One more, let's see. I guess I can address this one as well.
All right.
Thank you.
Can
Then
I?
I'm just gonna translate how we're gonna proceed, and then I think you can get started on the first question.
For sure.
All right, I think you can get started on the first question.
So let me
The
go
first,
back to it.
the
Yep.
first
So
question was, how was the project name Cartesi born?
so there was one before that one, but I can reply to the Cortese name first. So Cortese was started by some friends that studied together at university here in Rio, and all the 3 of them are actually mathematicians. Besides the 4th one, which is a Canadian person that came later, and because they are mathematicians, they wanted to pay homage to math itself, math history, and they started by using the Cartesian, like the Cartesian plane, and that's where the name came from. And several other projects within Cartesi actually started getting names of famous people in math world as well, such as Descartes or Noether, so on and so forth.
Got it. That's interesting. Um, you said where did you say the university was?
In Rio, here in Brazil, Rio de
In
Janeiro.
Rio. Got it. So we can move on to the second question that you've tagged. I think this is the one that I missed before. Here it is. What are the main differences and advantages of Cartesi compared to other layer 2 rollup solutions?
So, in a short answer, I'd say the advantages are twofold, and these come from the differences. First, it's app-specific rollup, so meaning you have your own little chain for your own app, meaning you don't share the resources. That means that you can have millions more transactions when it comes to scalability. And the second piece is actually the Cartesi machine, meaning that you have a generic computer. So, a general computing, meaning that you can use any language, you can use tooling, so you can have like a SQL database inside of it. So you're not very restricted when it comes to actually coding your dev.
I think we can move on to the third question. Yeah.
So, in order to not be repetitive, going to the last question actually helps explaining the third question.
Okay. So should I go for the fourth question first? The last
For
one?
sure, for
Okay.
sure.
All right. So here it is. How does Cartesi's virtual machine compare to Ethereum's virtual machine?
So, Ethereum virtual machine is what we call it, domain specific machine in this case, but any application. It could be a domain specific language. It could be other types of domain specific components. In this case, a machine. And what it means is it's just like a scientific calculator. It's very good, it's very useful, it's powerful, and it's very convenient because it is good for what it was made to do. However, it's very restrictive as well. So if you want to just solve some math calculations, evaluating some math expression, the scientific calculator is the way to go. But if suddenly you get some ideas and you want to start doing a spreadsheet or even just a game, it becomes very hard and very unsuited. It's very unsuited for that. So that's how the Ethereum virtual machine actually compares to everything else. And the Cartesi machine actually goes more in line with the virtual machines that we're used to. It's a general purpose machine, meaning that while it might not be as convenient to just evaluate math expressions, although that's arguable, it's actually very applicable to many types of applications, to many types of usage.
All right. And I think we can move on to the last question, right? And that was the third one that you tagged.
Right.
Yes. So are there any projects where Cartesi is a strong fit? What are they and why?
I'd say I'd start addressing the why, funny enough, which is I have this little summary that I try to give people after explanations, which is anything that you think that would be awesome built on Ethereum, and for some reason, because it becomes too complex or too expensive, for some reason you just feel like it doesn't fit on Ethereum itself, but it would be awesome if it could. Any of these types of applications, they are a very good fit for Cartesi, because Cartesi is basically, let's say, a very powerful version of Ethereum, so to speak. And that means that now you can have categories that are better fit for Cartesi for sure. So I'd say complex DAOs, they can leverage Cartesi because it's easier to express the rules of voting, of managing a DAO better using Python, for instance. Games, it's easier to develop the engine that verifies the state of the game and whether or not it's being played correctly, written using things like Python again, but then JavaScript, or if you want to go low level, even like C, C++, C Sharp. And also finally like DeFi as well, because currently DeFi, using the analogy before, is just like a calculator. And we see that several lending protocols, indexes, they suffer from the inability of actually processing a lot of data and inferring statistics and data indicators really about the health of the ecosystem. And we are seeing a lot of DeFi projects getting interested on how Cartesi works because it can process all this data and give back these indicators to the Ethereum ecosystem.
Thank you so much, Gabriel. We think this was a really high quality AMA, and we hope that our listeners got a lot out of this AMA. And, as much as we from the GitDeun team have learned from this presentation, this AMA as well. We're going to start wrapping things up, but before we bring this AMA to an end, we'd like to ask one last question. Here we go. How would you describe Cartesi in one sentence? One sentence only.
I'd say it's a Linux runtime box for your rollup system on a blockchain. Very tightly packed, sorry.
Thank you for your time, and well thought out answers, Gabriel. And thank you to the GitDeun community members who joined our AMA today to learn more about Web3 and blockchain through Cartesi, as well as our members from the Aslan Academic Club, especially all of you who have stuck with us from the beginning till the end, which I think is most of you. We've briefly mentioned our trivia/quiz time at the beginning of today's AMA, but in case you joined us late or need a reminder, we'll explain the rules and how we'll proceed with our quiz time again super quickly. At the end of every AMA we host on GitDeun, we will have a quiz/trivia session. Today we have up to 200,000 Korean won, or about $150 in US dollars, worth of prizes up for grabs for winners during our quiz time today. We'll proceed with the quiz session through text in the AMA-live channel right after the AMA, but please don't leave this voice channel. And one thing to keep in mind is we have placed a 10-second time limit on the AMA live channel. So, be careful with your answers. You don't want to just like spam the channel and lose your opportunity to win a prize. The quiz will include questions from today's AMA as well as non-AMA related questions. So make sure to stay tuned, join us in the AMA live channel, and we encourage you to participate. Once again, a huge thank you to Gabriel and the Cartesi team for joining us on the AMA, and to Cynthia as well, who I think is here. And to the Aslan academic club members for being active participants and asking really thought-provoking questions, really good questions at the end, as well as the pre-submitted questions. And to our GitDeun fam for sticking with us till the end. Good morning, good day, good night, wherever you're listening in from. Have an awesome weekend. Thank you so much, Gabriel. You're free to leave if you'd like, or you can, join us for the quiz. But the voice portion of the AMA is over, and we'll see the community members in our AMA live channel right after this AMA for our quiz time. Thank you so much.
Thank you, Barros. See you again.
Yeah, thank you guys. Thank you guys. This was awesome. Really good community, like you said. Really good questions. It was very fun to participate here. I'm honored. Thank you a lot.
Thank you. We
Thank
were
you.
honored as well. All right. Goodbye.
Bye
Bye bye.
now.
Yep.